Hello everybody. In the previous class we have seen the algorithm for the simplex method. Now we have gone through the LPP and how to solve the LPP. We have seen the algorithm using simplex method. Today I am going to solve an example using the algorithm to solve the LPP with simplex method. Shall we start now? Yes. Maximize z is equals to 5x1 plus 3x2 subject to the constraints x1 plus x2 is less than or equal to 2, 5x1 plus 2x2 is less than or equals to 10, 3x1 plus 8x2 is less than or equals to 12, x1 comma x2 greater than or equals to 0. Now the students who have missed the previous class, I would like to tell you the first equation what we have written, maximize z is equals to 5x plus 3x2, we call it as objective function. Objective function. Now you should remember always that the objective function should be maximization only. If they give by any chance minimization of z, then we have to convert the minimization z into maximization z, then only we can solve the problem. Now in the problem, now these subjective constraints are called are the inequations which are given. Now to solve the LPP by using simplex method, we have to convert all these inequations into equations by adding slack and surplus variables. Slack and surplus variables. Slack and surplus variable. Objective function, it should be maximization, you should remember, and the subjective constraints should not be any inequations. We have to make into equations by introducing, if it is less than or equals to inequation, we will use the slack variable, introduce the slack variable, and if it is by chance greater than or equal to equation, we are going to introduce surplus variable. Now the last equation is called non-negative restriction. Now an objective function with maximization and subjective conditions, subject to the conditions, all the inequations, and a non-negative restriction put together is called a linear programming problem. Now we have a problem, and what each equation or each sentence or each line will tell us we have seen. Now to solve this LPP problem, we have to this setup is called an objective function and subjective constraints, inequations, and a non-negative restriction put together is called canonical form. Now our task is to solve this LPP which is in the canonical form, should convert into a standard form. Later we have to solve it by simplex method according to the steps in the algorithm. So the first step is we have to convert the standard canonical LPP form into a standard form. Now how do we do that? As I said previously, to solve the LPP problem, we have to convert the subjective constraint inequations into equations. Now what are those equations? How we are going to convert it, let us see. Now First we will convert the subjective constraints inequations into equations. If the inequation is less than, we will add a slack variable. If the inequation is greater than or equals to, we will subtract the surplus variable. Now let us see. Maximize z is equals to 5x1 plus 3x2. Subject to the constraints, first equation was x1 plus x2 less than or equals to 2 it was. Now less than or equals to 2. If left side is less than right side, we want to make it into equal to. So what do? Something is less here. So we add some little value. That value we call it as slack variable. We added a slack variable so that the inequation has turned out to be an equation. Now the second equation also is a less than or equal to. So 5x1 plus 2x2, add one more slack variable because it is a less than or equals to equation, and make it to equals and put a 10. Now the third equation, 3x1 plus 8x2, again this is also less than or equals to equation. Add one more slack variable is equals to 12. Now what all we have added? Already in the problem we had x1 and x2, but the new slack variables also should be non-negative. Nothing should be negative, you have to add. So greater than or equals to, and here we have added S1, S2, S3, which are slack variables. That should be reflected in the objective function also. Without changing the objective function, we have to write 0 into S1 plus 0 into S2 plus 0 into S3. Now, these are cost to the variables. We have introduced a slack variable S1, S2, S3. Right? These S1 and S2, S3 should be reflected in the objective function without changing it basically. So what we have done? We have given the cost to each slack variable as 0. 0 into S1 is 0. So there is no change. 0 into S2, there is no change. 0 into S3, there is no change. Now we have converted a given LPP problem which is in the canonical form into standard form by introducing S1, S2, S3, and though to these S1, S2, S3 we have attached the cost of 0, and also we said S1 and S2, S3 are non-negative. Now we have created a problem from a given problem by not changing it anyway. Without any changes in the problem, we have converted into the standard form. Now the standard LPP is ready to be solved by the simplex method. Now we see what is the simplex method. What does the algorithm say about the simplex method? We have to draw a table called simplex table and solve the LPP by the steps given in the algorithm. Now what is that table? We will see. It is mandatory that we should draw the table and solve the problem. Now the table goes this way. What are the variables we have? x1, x2, and we have introduced x1 plus 3x2. Now, we have variable x1, x2, s1, s2, s3. s1, s2, s3. Now, look at the subjective constraint. What is the coefficient given to x1? 1, 1, S1. There is no S2 and S3 here. So the values for S1 and S3 are zeros and it is equal to X. So the first subjective constraint we have written. Now the second subjective constraint, 5, 2, 0, there is no S1, 1 and there is no S3, 0. And it is equals to 10. Now the third equation, you see 3 is the coefficient for x1, 8 is the coefficient for x2 and there is no s1, there is no s2 and the coefficient of s3 is 1 and that is equals to 12. Now the cost function which is given in the objective function. Now what is the cost given to x1 here? 5. The cost of x2 is 3. The cost of s1 is 0. The cost of s2 is 0 and the cost of s3 is 0. Now complete all the terms which are there in the LPP problem we have converted into a matrix wherein an identity matrix is present. So this identity matrix, we have framed our LPP problem in such a way that to solve it by simplex method, we require an identity matrix. The conversion is in such a way that we should get an identity matrix which is 3 by 3 identity matrix we got it. Now further we'll see what are the terms which will be there in the table. Now, in the table, where is the identity matrix? 1, 0, 0 is at S1 and 0, 1, 0 is at S2 and 0, 0, 1 is at S3. And next C. So, what is the cost of S1? The cost of S1 is 0. And the cost of S2 is 0 and the cost of S3 is 0. Here the complete table we have written by using our given problem which we have converted. Nothing is introduced here. Whatever is there in our standard LPP problem, that numbers only we have put it in a table form, which now we will apply the simplex method and solve the problem. Now, we have to find out Zj minus Cj. Now tell me, what is Zj here? There is no Zj in this term. We have to find out Zj such that Cb, summation of Cb into Xi. Now what does that mean? Cb is 0, 0 into 1, 0 into 1, summation it is, plus 0 into 5 plus 0 into 3. So what do you get here, Zj? 0 into 1 is 0, plus 0 into 5 is 0, plus 0 into 3 is 0. So your Zj is 0. So 0, Zj is 0 minus Cj. Cj is what? 5. So it is nothing but minus 5. Now again, Cb into x2 you have to do. All are zeros. 0 into 1 plus 0 into 2 plus 0 into 8, which is nothing but equal to 0. Zj is 0, Cj is 3, so it is 0 minus 3 minus 3. Now here also 0 minus 0, it is 0, 0 minus 0, it is 0, 0 minus 0 is 0. Now the next step is, we have to search for the most negative value. Which is the most negative value here? Minus 5. Yes, the one which is going away from the 0 is most negative. Next, taking that minus 5, that means this basis will enter into the table, and what will one, now here these are bases. Now the identity matrix, simply if we want to put it the other way, that means we have to take an identity matrix should come into our actual variables. These we have introduced. Now this is entering into the basis because it is most negative one. Now xb divided by the basis which is entering, that is x1. So x1. xb is what here? 2 divided by 1, which is 2. 10 divided by 5, which is 2. 12 divided by 3 is equals to 4. Now out of these 3 also you have to search for the least number. So which is the least one? There is a tie between the first row and the second row. But if there is a tie, we are going to choose the topmost one. If there is tie in this row, what we are going to do is, we are going to take the leftmost one. This is the tip you should remember. If there is a tie here, we are going to choose the row whichever is the topmost. And if there is tie in this row, what we are going to do is, we are going to choose whichever is leftmost. This you have to remember and go ahead. Now, what happens if somebody chooses this? If somebody chooses this, they will get the other answer, which may not be the correct one. So that everybody should get a single answer. That means we have to choose, if there is a tie over any number here, the topmost one we have to choose, and if there is any tie here in the Zj minus Cj, we have to choose the leftmost one. Now, where does these two arrows cross? Here. This number is called pivot element. Now, pivot element should be equal to 1 and the remaining element in that column should be 0. Now our task is, we have already the pivot element as 1. Now we have to make the other elements which are in that column as zeros. How we are going to convert and where we are going to put, we will see. Now we have to take one more table, the same table, we have to repeat it and we have to convert the elements in the pivotal column zeros. How we are going to make? Here we are going to use our simple matrices only for the conversions of rows and columns. Now this is your second table. Rather we call it as iterations. Second iteration, CB, YB, XB, and we have x1, x2, s1, s2, s3. Now, so first row should be as it is. 2 because the element, pivotal element is 1. 1, 1, 0, 0. There is no change. Our condition in the algorithm is we should find out a pivotal element. How we are going to find out the pivotal element? We are going to find out Zj minus Cj. In that Zj minus Cj, the most negative column we have to choose. In this particular problem, minus 5 is the most negative element in this row. So we have chosen this column, x1 column. And we have found out xb by x1. In that 3, whichever is minimum, we have to find out. In this particular problem, there is a tie. So if there is a tie, we are going to choose the uppermost element. So that row and this column, intersection part, we call it as pivotal element. Now, wherever the pivotal element is there, that pivotal element column में all the other elements should be 0 and the pivotal element should be 1. To convert the other elements into 0, we are going to use our matrix conversion method. How we are going to do? Now I have to make this 5 into 0 as 0. How am I going to take? Now this is the old R2 minus, I have to get the 0 here. Here it is 1. Now next is 0. How do I get 0 here? I have to minus this row, old R2, by using the 5 new R1. Now, what are the values we have in the old R2? Old R2 may we have 10, we have 5, we have 2, we have 0, we have 1, we have 0. Look at the old R2 row. What are the values we have? 10, 5, 2, 0, 1, 0. Minus, what are the elements which we have in new R1? That we have to multiply with R5. So we have 2, 5 into, we have 1, 5 into 1, 5 into 1 again, 5 into 0, 5 into 0. Now you carefully watch what I have done. I am using the matrix conversion method where I am keeping my pivotal element as 1. Here already in the problem we got 1, so we did not convert it. We have put as it is the row 1. And we are calling it as a new R1 because it is in the new table. So those values, new values I have written, but the old it is 5. This 5 has to become 0. So what I have done, 5 into all the elements I have done. Now you see, 10 minus 10, 0, 5 minus 5, 0, 2 minus 5, it is minus 3, and 0 minus 5, it is minus 5, 1 minus 0, it is 1, 1 minus 0, it is 0. Now the new second row will become 0, 0, 3, minus 3, minus 5, 1 and 0. I have converted the second element of a pivotal column into 0. Now my task is convert the third element also into 0. How am I going to do the third element into 0? You watch carefully. Old R3 minus, what is there here? 3, and I have to get 0. So how am I going to get 0? 3 into new R1. Now old R3 mein what are the values you have? 12, you have 3, 8, 0, 0, 1. These are the elements of old R3. Now minus 3 into new R1. What are the elements of R1? 2, 3 into 1, 3 into 1, 3 into 1, 3 into 0, 3 into 0. Now what are they? Let me tell you. 12 minus 6 is 6, 3 minus 3 is 0, 8 minus 3 is 5, 0 minus 3 minus 3, 0 minus 0, 1 minus 0 is 0. Now the third row elements are 6, 0, 5, minus 3, 0 and 0. Now tell me where the identity matrix has shifted. Now the identity matrix 1, 0, 0 has shifted to x1 and 0, 1, 0 is at s2 and 0, 0, here it is 1, I'm sorry. 0, 0, 1 has shifted to, it is there at s3. Now what is the cost of s1, x1 is 5, the cost of s2 is 0, the cost of s3 is 0. Now what is our next task? We have to find out zj minus cj. Same steps we have to follow. How do we find out zj minus cj? cb into 1 plus 0 into 0 plus 0 into 0. 5 into 1, 0 into 0, 0 into 0. It is nothing but 5. 5 minus cj. What is the cj? 5. 5 minus 5 is 0. The next is 5 into 1, 0 into minus 3, 0 into minus 5. Anyway, there are two zeros. We will multiply. I think we can forget these two rows and we should concentrate here. 5 into 1 is 5. Minus 3 is 2. 5 into 1 is 5, minus 0 is 5. 5 into 0 is 0, 0 minus 0 it would be 1. 5 into 0 is 0, 0 minus 0 will be 0. Now you watch carefully. Here zj minus cj, all positive values we got. Now we will stop here. All the values, until and unless we should do iterations where we get all the zj minus cj's as positive. And we can derive our answer from here. How do we derive? x1 cost is equals to 5 and s2 cost is equals to 0 and cost of s3 is equals to 0. This is what we got from the second iteration, where zj minus cj values are we call zj minus cj values as our answers. But what was our maximum z? Maximum z is equals to, let me check, 5x1 plus 3x2. 5x1 plus 3x2. So our x value, what we got from the table? 5 into 5. And is there the x2 values? No. So what do? We will put 0 for that, and your answer maximum Z is 25, which is your required answer. You can maximize your profit by taking X1 to be 5 units, and your profit maximum Z would be, if you invest anything on the business, you would get maximum profit as 25. These are the steps. By following Simplex method, we can solve a linear programming problem. I think all of you all are clear. Thank you.